everyone, today I am going to talk about the azeotropes. An azeotrope is the mixture of two or more liquids whose proportion cannot be altered by a simple distillation or fractional distillation. And we know that the conditions for the fractional distillation, if we have the binary solution, let's take we have two components A and B. Then for the fractional distillation, the mole fraction of component A in liquid phase must not be equal to the mole fraction of component A in vapor phase, and similarly XB must not be equal to the YB. When the azeotropes are formed, the mole fraction of vapor and liquid is same. That means X is equals to Y. Okay. So azeotrope you can see over here in this graph, in this diagram, when the two vapor and liquid curves meet one another at any point at any given temperature or constant temperature, what they form is called azeotrope. So this point is called, here you can see it's azeotrope. And once the azeotropes form, we cannot separate them because their mole fraction becomes identical. That means at this point, XA is equals to YA. That means जितना भी if we have two propanol and water, so जो mole fraction water liquid में है two propanol के same mole fractions कहाँ पर हो जाएंगे vapor phase में भी हो जाएंगे. So it becomes very difficult. And now we know that Raoult's law for ideal solution, because Raoult's law shows the behavior of ideal solution. So Raoult's law for ideal solution cannot predict the formation of azeotropes, but some of the other equations like Wilson equations, Margulis equations, these equations can predict the formation of azeotropes for some of the mixtures, because they can form different for formation of azeotropes. Once the azeotropes can form in any system, so there are number of variation and number of formation. Okay, so now let's take there are some conditions to form a azeotrope. The first condition is there must be a binary solution, liquid solution, both are in liquid phase, right? Liquid solution, that means there is one solute and solvent. Okay. The next is their composition must be fixed. So fixed composition, that means 2 propanol plus water, so that must be 95% propanol and 5% water. So now it is fixed. Third is boils at constant temperature. And fourth is their separation is not possible by simple or fractional distillation. So separation is not possible by fractional distillation. And the last one is X is equals to Y. That means the mole fraction in the liquid phase must be equal to into the vapor phase. Now let's discuss this diagram. So here you can see मैंने आपको क्या बोला 95% propanol and 5% water. This is your XY diagram. Okay, so X mole fraction in liquid phase, and this is, it shows the y-axis shows the vapor composition. Okay, so when you here what we have pure water, right? You can see over here the pure water is there, and then when you move on, so 0 to 1, similarly 0 to 1. Okay, so when you can see over here this line shows the Raoult's law, and this mixture shows the positive deviation, right? So when you rise the temperature and pressure, it shows the positive deviation. So at over this range of composition, here you can see that Y, the mole fraction vapor phase is more than the mole fraction in liquid phase, because more propanol is present and more propanol in the vapor phase than in the liquid phase, right? And because why? Because the temperature of because 2-propanol is more volatile as compared to the water. So the boiling temperature of propanol is approximately 355.5 Kelvin, and we know that the temperature boiling temperature of water is 373 Kelvin. So obviously this is lesser. So ये 2-propanol पहले boil होना start हो जाएगा, right? So they form a more vapors, and the mole fraction of propanol in vapor phase is more as compared to the liquid phase. And then they form the azeotropes, right? That means their boiling point is become, they boils at constant temperature, right? They boils at constant temperature, and then the mole fraction of vapor phase, mole fraction of propanol in vapor phase is equal to the mole fraction of propanol in liquid phase must be same, and then at this point they form a azeotropes. So here you can see this is the positive deviation, right? And for over the certain range of this, it shows the negative deviation. This curve shows a negative deviation. Right, now let's talk about the minimum boiling point azeotropes and maximum boiling point azeotropes. Now let's discuss the phase diagram of azeotropic mixtures. Azeotropic systems are those which shows a maxima or minima on TXY and PXY diagram. A mixture which shows minima on TXY diagram and maxima on PXY diagram is known as minimum boiling azeotrope, and the mixture which shows maxima on TXY diagram and minima on PXY diagram is known as maximum boiling azeotrope. So to understand this, let's let's take the example. Here we have chloroform and methanol. So first thing is to fix the what? Composition. So you can see over here the mixture of methanol is around 67%. Then rest is chloroform, right? So chloroform कितना है? 33%. So here you can see we have formic acid and water mixture. So for water, again you need to fix this. So around 68-69% of water, and the rest is formic acid. So rest is formic acid, which is approximately 32%. Okay. Okay, so to understand this, we have the mixture of methanol and chloroform, right? So this is your PXY diagram and TXY diagram. On PXY diagram, it shows the maxima, and on TXY diagram, it shows the minima. And this type of diagram is called minimum boiling azeotrope. So these are called minimum boiling azeotrope, which shows the positive deviation. Boiling azeotrope, which shows what? Positive azeotrope, or these are called, which shows the maxima on TXY and minima on PXY, is called maximum boiling azeotrope, right? And it shows the negative deviation from Raoult's law. So to understand this, see, we have this diagram, okay? Let me join these 2 points, and we have methanol and chloroform. Okay, so this is a straight line. now थोड़ा सा मुझसे straight नहीं आया. So this is the straight line. ये क्या दिखा रहा है? यहाँ पर क्या है? We have pure methanol, and here we have pure chloroform, right? So when we rise the pressure, temperature भी बढ़ेगा, right? And एक point पे आपको क्या मिल जाएगा? This is your, it shows the positive deviation. This mixture shows the positive deviation, methanol and chloroform. This is the one example of mixture which shows the positive deviation, right? So यहाँ पर आपने क्या किया? Positive deviation देखा, and once एक पॉइंट आपको मिलेगा वहां, देयर द मैक्सिमम यू अचीव द मैक्सिमम वेपर प्रेशर. ओके, जब एक बार आपको मैक्सिमम वेपर प्रेशर आ गया एंड एट दिस पॉइंट एजियोट्रॉप्स फॉर्म होंगे. इफ यू एक्सटेंड दिस ऑन TXY डायग्राम, तो एट द सेम कंपोजिशन जब वेपर प्रेशर हाई होगा, दैट मीन्स वेपर प्रेशर मैक्सिमम एंड देयर इज ओनली वेपर्स, वेपर्स फॉर्म हो रहे हैं, तो उसका बॉइलिंग टेम्परेचर क्या हो जाएगा, ऑटोमेटिकली कम हो जाएगा, राइट. सो दैट्स व्हाई दिस ऑन TXY डायग्राम वो क्या होगा, मिनिमम होगा, राइट. सो ऑन TXY डायग्राम इट शोज द minima and on PXY diagram it shows the maximum. In the negative azeotrope, so here you can see this, it shows the negative deviation from the Raoult's law. Let me join these 2 points. So you can see it shows the negative deviation from Raoult's law. Okay, and when we have the mixture of water and formic acid, so when it reaches to this point, right, so here what happened in the at this point, because the vapor pressure is decreasing or very low, देन देर इज नो वेपर्स आर फॉर्म. तो जब वेपर फॉर्म ही नहीं होंगे तो फिर क्या होगा आपका, आप यू नीड टू बी टेम्परेचर क्या करना पड़ेगा, हाई टेम्परेचर होगा, मैक्सिमम टेम्परेचर होगा. सो दैट्स व्हाई इट शोज द मिनिमा ऑन PXY डायग्राम एंड मैक्सिमा ऑन टेम्परेचर TXY डायग्राम. ओके, सो नाउ आई होप यू अंडरस्टैंड दिस कि यहाँ पर क्या हो रहा है, यहाँ पर आपका PXY में मैक्सिमम क्यों दिखा रहा था, बिकॉज इट शोज द पॉजिटिव डेविएशन एंड द वेपर प्रेशर ऑफ दिस कंपोनेंट इज वेरी हाई. जब वेपर प्रेशर हाई है, राइट, वेपर्स ही वेपर्स फॉर्म हो रहे हैं, तो ऑटोमेटिकली उसका टेम्परेचर क्या हो जाएगा, कम हो जाएगा, राइट. And in this diagram where it shows the negative deviation from the Raoult's law and we have the mixture of water and formic acid, so here the azeotropes are formed where when the vapor pressure is less, of vapor pressure of at this point pure boiling point of water and pure boiling point of formic acid. Okay, दोनों का boiling point है, and at this point the azeotropes are formed where x is equals to y. Similarly here also x is equals to y. Here y is more than x and here x is more than y. Similarly here also, so x is equals to y, and here the vapor pressure is very low. Because the vapor pressure is very low and no vapor formation takes place, so temperature automatically क्या होगा, rise होगा, increase करेगा, and when the temperature increase करेगा, so you will get the maxima on TXY diagram and minima on PXY diagram. And this is for those who shows the negative deviation from the Raoult's law, and the mixtures, those who shows the positive deviation from the Raoult's law, forms the minimum boiling azeotropes and they forms the maximum boiling azeotropes. Hope you will be able to understand this concept. Thank you.